Right, that's these four are complete. They're actually adapters. They get fitted in a top radiator hose of an engine on generator sets, and they're adapters like for a low coolant probe to go into. Right, on with the next mission. Well, g'day, Max here again. Welcome back to the shop after a week's break. So what we're going to do this episode, or this video, is we have to make a couple of 2¼ inch British Standard Whitworth nuts according to this drawing. So we'll bring you down and show you the scenario. So I think I briefly touched on this a couple of weeks back. I was dropped off this drawing to make these 2¼ inch British Standard Whitworth nuts, which is not really a problem, but it can come with some problems. Okay, the problem is the sample part that it screws on was like a 5 or 6 hour drive away. So what I had to do is make a gauge, which is, according to pitch diameter, 2¼ inch British Standard Whitworth. Now, then I made up a ring gauge that screws on, and there's a neat fit on there. It doesn't have play in it at all, but it's got minimal clearance. So what I wanted to do then, or what the plan was, this was going to be sent down to the mating part for a test fit. Then I would know it would either just about screw on or screw on like a cock in a shirt sleeve or whatever. And then that way I can adjust the thread to suit. And that way I'd have a higher than average chance of the nut fitting without having the mating part in front of me. So I've got our 2 blanks turned up, what we're going to get our nut out of. But in the interim, they brought the shaft up to me. So that's our thread in question. Bit of a shallow square thread on the other end of it. It's part of I'll just say it's part of like a shock absorber mechanism, aka part of a recuperator. So our thread, when we screw our test nut on it, goes up 2/3 of the way. I think there's some damage in the thread, but that's a really good fit there with no play, just minimal clearance. Even turn it around the other way. This proves that you got your threading tool square. If it only screws on one way, quite often if you've cut the thread with your tool on the piece a bit, you'll find it will screw on one way but not the other. So I'm going to take this as good. What I will do is I'll just give our nuts probably another couple of thou clearance, and I suspect the last couple of threads on this just need a bit of a clean up. Whoops, dropped it on the floor and it rolled under the cupboard. So what we're going to do, we're actually going to cut our hexagon first. Now the hexagon doesn't finish up with sharp points. There's a slight OD radius of the part which we will finish up with, and that's what we're going to be gripping more than likely when we go to cut the thread. The reason we're doing that is it makes these easier to hold before we thread them to do the hexagon. So hopefully they'll stay secure in the lathe chuck when we thread them. This should be alright. I don't anticipate any problems. So we'll get these set up in the milling machine and knock out our hexes. So we're going to use Olga here, and we'll get our indexing head set up and indicated in. I hope that this indexing head never ever has to go back on the Bridgeport, because it's way too heavy for a Bridgeport, and it's a bit of a mission, you know, swapping them from one machine to another. And to rectify that anyway, I'm going to, as soon as I get funds for the tubing, I'm just going to make a small swing gantry here, so I can swing, whether it be indexing head, rotary tables, whatever, on and off the machine. Our V-blocks just missed out on their first paying job to go through them, as the material was not available here in Western Australia. It's only sold in the eastern states. That would be induction hardened chrome bar. So now I'm more aware of that. It's something I've just got to be wary of in the future. But yeah, they would have had their first paying job in them last week. And the other thing, if you recall, if you watched the series when we did the V-blocks, when we did this cut, now we should have, well, what happened when we were halfway through cutting the second one, the saddle on the milling machine just very slightly just moved across a little bit. That would be partly due to the backlash on the thread, on the feed screw. So what I had to do was, well, the table locks weren't working as they should be. So to rectify the fault with the table locks, it has one on either side, so it has dual locks. These keeper plates here, the guide keeper plates for the boxways, and it looks to me like they've never ever had an adjustment in their lives. Bear in mind, this machine was completed in the factory in Russia in 1989, so it wouldn't have been sold here in Australia probably till 1990. So what I had to do was machine the undersides. I didn't film it because it was a lot of taking them on and off and trial and measurements. And that, now we've reduced the clearance. The way it's designed, this is a steel keeper and has these slots under here which act as a bit of a flexure. So when you engage the lock, it pushes on a cam, pushes a plunger down on that half, and it causes the inside half to kick up and lock the table. So I'll just unlock that. Yeah, another repair I've got to do is tighten that up. So yeah, I had to sort that out, and now the table is locking well. So that's another little job carried out for Olga. So in the midst of while all that was going on, I was working on the two chip trays for the JFMT. So they're all sort of sorted out now. I have valves on so I can isolate the coolant from one tank to another should the need arise. Well, the need will arise first time I fill it up, because I'm only going to be filling this one initially. So the coolant pumps are all hooked up. And we just have a temporary coolant nozzle here. It's a bit small, this one, but I do need something, and this was sitting around doing nothing. So I do need to order a 3/8 one for it or something like that. And then all we got left is the splash guard, well, the rear, splash guard you call it, that bolts onto the headstock, and it comes down to about halfway down the lathe. So I still have to clean that up and get that bolted up. Now, I did a bit of shopping, and I brought some 24 volt work lamps. These aren't cheap either. So one of these will go on the machine here. So we'll have to make up a plate for it to mount on. Probably something that picks up off these two holes, or these two bolts here, or at least one of them, spans across, picks up here as well. I would like to move the coolant pipe just down this way and maybe have it come up here or something, and then I can mount the light here. So I'll make a flat plate that sits there and spans these holes. And also want to leave a bit of room on it too, because I'm umming and ahhing this machine is getting a DRO, so whether I mount it off the same plate, so the DRO reader is here, or I pick up off these two holes here with a plate, come across and have the DRO on the headstock. And if I did that, I'd have it on a slider or an arm so it can be pulled across. Not sure yet, so that's still a work in progress. Yeah, well, two of those lights are for Olga. Yeah, so she'll have one mounted here where that plate is. I'll just have to make up probably a different adapter plate. And in the same spot on the other side where I got this little office desk light, she'll mount there as well. And they're 24 volt those, so they'll just be directly wired into the transformers on the machines. Right, I suppose I'll get this indicated in and we'll get our hexes sorted out. But not before I've packed up my mess here on the Bridgeport. And my mess here as well on Hong Fak Wong. That's still the mess from when we were doing the V-blocks. And I was also doing a bit on the DSG as well. So yeah, cleaned up the beds. They're all ready now for some measuring, and cleaned up the tailstock base, and just in the process of going through all the other tailstock parts at the moment. So this will all be on a separate video series, the DSG repairs. And in the background over there, those box section aluminium pieces. I got these out of my friend's scrap bin from his fabrication business, and I'm going to make these into tooling racks, predominantly for Olga, so we can drill some holes in and have something to set all of our tooling holders in, and arbors and whatnot. So, right, where were we? Going to indicate that indexing head in. So we'll get our rings set up in our indexing head. What I'm going to do is I'm going to put a backing ring behind our part. That'll sit on the jaw. So when we put our part in, it gives us a little bit of clearance between where we're cutting and the jaw, so we don't want to hit the jaw with the cutter. So I just sort of centralise that ring by eye. Just nip up our chuck, and we're using the tailstock because we are only gripping on, well, we're gripping on less than half of the length of this ring. It's only a little bit. So I found this little disc in my scrap pile, so that'll prevent our part being reefed out. We tighten that up. Tighten that up, and I'll just lock off the tailstock. Okay, so I'll go and get a cutter, because our part is approximately 22 millimeters wide, and the cutter in the machine at the moment is a 3/4 cutter, which is, I want to take this through in 2 passes because you know, we're only quite gingerly held here. So we'll get a cutter about half the width, something around about a 1/2 inch cutter, something like that. So what we'll do, we'll take our hexagon to full depth all the way around with the 1/2 inch cutter, and we'll move the table across and just take off the remaining amount. Okay, minor change of plan. We've got this Morse 1-inch end mill, so I think we're going to just do it in one hit. All that we'll do is we'll start from this side and travel across. That way all of our cutting forces are directed at the chuck, and it's going to be far more stable. So, and I only have to do, you know, index at once, you know, for the 6 positions. So we're not going to, we'll just run it through on a very slow speed, a very slow feed rate, and just amble along. So that's the plan. That'll be our depth. So this will probably wander around a little bit. We'll see how it goes. So we're going to amble through this on 400 RPM. It's a 1-inch cutter and 125 millimeters a minute feed rate. So our maximum depth of cut as we come to the top of the circle will be 2.9 millimeters. And I'll just use a bit of suds in the spray bottle just for a bit of lube. Okay, that all looks all right. Yes, all right, I'll bring the cutter back across. I could probably up that feed rate. Probably, if we take it up to the next one, which is 160. Let's see how that goes. Well, I don't know, the camera cut out on that last one, so I've just emptied all the photos off it. So we'll go again. The higher feed rate, yeah, came out. It was good. So we'll index round again. So we've got 6 turns and 26 holes on a 39 plate. Lock it off. The only trouble with these larger machines, you end up doing a lot of mileage, you know, walking around everywhere. So, right, here we go again. Right, we're around all 6. That was quite quick, except for mucking around with the camera. We'll get a measurement. 2770 is our dimension across flats. This is drawing is dimensioned in inches, or 70.35 millimeters. Probably 3/4 of a thou. Three-quarters of a thou under. I think that'll be fine for a set of spanner flats. Right, well this one can come out. We'll just run the other one through on the same settings. Walk halfway around the world. Right, where's the chuck key for the indexing head gone? Right under my nose as per usual. Okay, so the little radius left on the crests, that's where we're going to grip it when we thread it. It is supposed to be like that. That's how the drawing is. So we'll get the other one in, and that's our ring, our spacer. Okay, that's that one done. Yeah, same, 3/4 under, that's fine. Right, we'll get this out, deburred, and then we'll head over to the lathe, and we have to get set up for screw cutting. 2 1/4 inch British Standard Whitworth, 10 threads per inch. Oh, Olga here, she likes those big cutters. Imagine the clanging and carrying on if I did that in a Bridgeport. Right. Take our chuck key out. I brought this little vise a while back. At the railway workshops, there's a group there sells second-hand and old tools and things like that every now and then. It's an old 3-inch Joplin made in Australia. So I want to get rid of these hard knurled jaws and put a set of mild steel jaws in, and maybe also make up a set of aluminium jaws for it. Another one of those projects that, yeah, if you don't do it, they mount up. Took me about 6 weeks to get this bolted down. So we're just going to hold our nut blanks in the soft jaws. This disc will preload the jaws, and I'll just bore the edges of the jaw out to take the nuts. Yeah, got a way to go yet. Just boring it through till we remove the remnants. There's still a little bit in the middle of the jaw from the previous job. Something like that. Let's see how we're going for diameter. Yeah, that'll work. Okay, so I'm just going to go in with the tool and just undercut the very corner. Okay. put an indicator in the bore and just see how that's all travelling. That's within a thou there. Two thou on the face. I'll leave that. Let's try another one, see how it comes out. About 5 thou on the face. Two thou on the bore. Can't remember how well these were sitting when I first bored them out. Let's just try a different position. So that's running good there. That's within a thou. Check the face. We can take a skim cut over the face just to true up that last thou or whatever if it needs it. Yeah, just over 3 thou, 3.5, 3 thou. Okay, I'm happy with that. I'm using the soft jaws with the shoulder. Really holds the part nice and solid. So if we'd had to use the standard jaws, there is a chance the part could wiggle around and shift. So what we're going to do, we'll get set up. Actually, what I'm going to do first, I'll get a tool set up and we'll do the chamfers that will be on the rear side first. So we'll get them all chamfered. So we're going to run the lathe in reverse and we'll just use this boring bar to do our chamfer. Just make sure we've got clearance on the chuck jaws. We're just going to eyeball that in using this insert. I'll show you. We'll just move our tool post around. About there. That'll give us a approximate 30-degree angle. Only has to be approximate because Whitworth is 55, so that's 27.5. But it's close enough for a thread chamfer. So I'm just setting the 0 dial on my carriage. That will tell me our depth in. And I'll estimate where we got to be. Okay. Make sure we're clear. just about. That's all it needs. Bit of a burr on the inside, not happy with that. Let's just adjust this tool a bit. It's got it. Okay, let's get our tool set up for screw cutting. Let's just check how this part has actually ended up in there. So half a thou, that's good on the face. Check our bore. Thou and a half, that's nothing to write home about, so we'll let that slide. So I'm just going to check our bores because seems like a lifetime ago when I made these and I can't remember what I bored them to. Just a shade under 2.124. So going by original calculations, should have been bored to 2.122, but I've got it marked underneath that, bore them to 2.130. So that must have been after I done our sample one. So we'll take it to 2.130. I'll just take 6 thou out of it. Well, okay, time's getting away from me as per usual, so we'll break this one off here, and all going well, part 2 will be following directly. So cheers, thanks for watching, and watch out for part 2.